what is the probability that he makes exactly 10 of them? Okay, so I'm starting to work through the solution here. It's a binomial problem. He's taking 12 free throws. Okay, the key here is that he's repeating something 12 times. Okay, and every time he takes a free throw, there's only two possible outcomes. He either makes the free throw or he does not. Okay, so and because we said it's independent of everything else, that means the probability that he makes it remains the same throughout. Okay, so we've got a binomial problem with n equal to 12, p equal to 0.88, and we are curious with if he makes exactly 10. Okay, so we're going to have 12 choose 10, 0.88 raised to the 10 times 0.12, or 1 minus 0.88 raised to the 2. Okay. So when I run this on the calculator, I'm going to do 12 choose 10 times 0.88 raised to the 10 times 0.12 raised to the 2. And that gives me 0.264. So. This is what I have right here. Suppose we can go to our studio and just check d binom 10, 12.88. And R agrees with me. So let's go. Okay. What is the mean number of free throws that we expect Chris Paul to make? Answer there? Yeah, n times p. So we would do 12 times 0.88. I think somebody said 10.6, but I'll just verify. 10.56. And if I asked for the standard deviation, you would give me square root of n times p times 1 minus p. Okay. So that'd be 10.56 times 1.12, and I would take the square root of that, and I would get 1.1257. Yeah?
So no rounding rule for something that's discrete.
Right, so there's no continuity correction or anything like this, because here we are using the binomial distribution. Exactly, okay? So if we were to do a normal approximation to this, which we shouldn't do, okay, we would have to take into account a continuity correction, okay? But here we're using the binomial equation to get an exact probability. There's no, this is not an approximation, this is an exact value. And over here, I'm just asking for the mean and standard deviation. Which there's no continuity correction or anything like that. In terms of rounding, you round to whatever you see fit. I would just say generally keep as many decimals as you're comfortable with.
I didn't like you'd say 10 because it's a...
Oh, right, no. The mean here, so yeah, we would not say 10 or 11. The mean is a decimal, okay? So it's fine that the mean is a decimal. Of course, when he actually plays a game, he's either only going to make 10 free throws or 11 free throws or something else, okay? He can only make a whole number of free throws, but in terms of the average, okay? The average being if Chris Paul played, whatever, 82 basketball games, and every single time he played a basketball game, he shot 12 free throws, which would never happen, but if he shot 12 free throws every single game, what would the average number of free throws be that he makes? That average should be around 10.56, okay? The mean of the random variable is 10.56, of course, sampling, averaging the scores from 80 basketball games or whatever, that's just a random sample. So, yes?
In terms of rounding the standard deviation, when you are using a normal approximation, for example, on the test, I rounded to 3.6 instead of the 3.5 or whatever.
3.57, okay.
Yeah, and that gave me an answer of 0.1056 instead of 0.1038. And then
Okay, so on the quiz, if you got that, I would not take off points, okay? I mean, that's...
Okay, but would that affect our answers on the test, for example, if we...
So the test is multiple choice,
Right.
okay? And so you're limited to answers to pick. And I'm not going to have one answer choice be 3.56 and another one be 3.6 or something like that, okay? Because that sounds very evil to me or something, okay? But, you know, I will have answer choices where maybe the standard deviation, like maybe, you know, the standard deviation is, you know, square root of sigma y minus y bar squared over n minus 1, okay? And so maybe one of the answer choices will be what you would get if you divided by n rather than n minus 1, okay? So if you make a mistake in your calculation, maybe your answer choice will line up with an answer choice that's available, but that's because you made a mistake. But, you know, in terms of, if you get an answer that's very close but not exactly, I would just say go with that one, because it's probably just a difference in opinion on rounding, okay? Like maybe I rounded to 3 and you kept 4 decimals or something like that. I would just say the one that's closest to it, okay? I don't think I have very many questions where your answer choice is none of the above, where you're like, well, I got 3.88 and the answer choice there is 3.90. Do I choose 3.90 or do I choose none of the above? You know, that shouldn't be an issue, okay? That should not be an issue. And of course, if you have any questions during the exam, you can always raise your hand and I'll try to answer as much as I can without breaking the, I guess, integrity of the exam. How are we feeling?
I just have one more question about graphs.
Okay, sure.
How do you think you'll translate that to multiple choice?
Yeah, maybe I'll have a box plot. Maybe the box plot will look like this, okay? Oh, it's quite nice writing on this for little charts here. Okay, so maybe I have a box plot that looks like this, okay. And then, so probably I won't, like, your answer choices won't be graphs, but maybe I'll put a graph up here, and I'll ask something like, what is the range of our data? So of course, in real life, the graph would be better, more precise than what I've drawn here. But what would we? What would you do for the range? So yeah, the range of our data. Yeah, it looks like 160 or 159, and over here it looks like 100 or 101. So your range, maybe you'd be 160 minus 100, and you'd say the range is 60, or, you know, depending on how accurate the thing is, maybe it's 159 minus 101, whatever, a range of 58, okay? Either of these I would say is probably correct. And I would not have both of these as answer choices or something. Okay? I would try to make these very clear, okay? If I ask, you know, what percentage of the data is less than 120? And you would say, so 120 is located at, so this is Q1, right? This is Q1, this line right here is the median, and this is Q3 over here. So from our graph, it looks like Q1 is equal to 120, and so that means what percentage of the data is less than 120? 25%. Okay. I don't know, something like that. Yes.
If there was an outlier at like 180 and we're solving for the range, would we use the upper fence or would we use the outlier as the top bound?
Yeah, you would use the outlier is part of your data, okay? So, well, based on my IQR, I don't think 180 would be an outlier. But if there were an outlier here or something, that is part of your data and that would make your range much larger. And that is the case, yeah. Okay, anything else? What?
It's late.
It's late. It's 9:54. Okay. All right. Well, we'll end there. And, good luck. Good luck as you guys study. We'll see you guys next week.